Hey there, welcome back to this channel, and today we are going to talk about API gateways. Now, if you're watching my videos for the first time or if you're new to this channel, then I would highly recommend that you should check out the earlier videos. So just to let you know that this particular video is a part of a complete series, and if you want to get some context into the source code that we have used in this session, I would highly recommend that you should watch the earlier videos. Now, how should you watch the earlier videos? So in the description of this video, if you head down, you will find the description and you will get the link to the entire series there. So be sure to check it out. Now, talking about this particular lecture or session, we are going to cover API gateways. Now, we will begin talking about what are API gateways, why are they needed, and we'll talk about how we can implement API gateways into our Spring Boot projects and make them a part of our microservices architecture. We will learn about setting up the entire API gateway and how we can move requests or route requests through the API gateway. And in the process, you will see how API gateway adds value to your architecture. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so, because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video, and turn on the bell notifications. Also, feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Hello and welcome. So let us start talking about what is an API gateway. So before we talk about API gateway, let us do a recap of the basic premise of microservices. So in microservices architecture, the monolithic application is broken down into small loosely coupled services, and each service corresponds to a specific business functionality and can be developed, deployed, and scaled independently. So here you have 3 microservices, okay, and they all serve a specific business purpose and they are independent. Now, as you can imagine, when we have numerous services interacting with one another and client applications, the complexity of managing these interactions increases significantly. And this is where the API gateway comes into play. So now, since we have multiple microservices, we have a problem. So what is the entry point for our application and how should we interact with it? So each and every microservice will have different service URLs from where they serve their specific functionality. But for a user does not care about your underlying structure. So for user, your application is a single entity as a whole and it has to function as a whole. Behind the scenes, you can have multiple services serving each functionality. That is fine. But for a user, the application is a single unit and not multiple microservices tied together. So the question for a user or from a user perspective is, what is the entry point for me into your application? Because everybody has their own host URLs. So I need a single entry point, and that is where API gateway comes into picture. So you can think of API gateway as a special type of reverse proxy or something that routes the request from the client applications to the appropriate microservices. And it acts as a single entry point for the external client request. Now this simplifies the client side experience and it also hides or masks the internal complexity to the external world. So API gateway serves this particular purpose and they are very useful when it comes to microservices architecture. So let us talk about some of the advantages that we have with API gateways. So the number one advantage is the encapsulation. So API gateways encapsulate the entire system architecture and provides a level of abstraction between the client applications and your backend microservices. This means that changes made to the microservices, such as adding new microservices, modifying existing services, and even changing the service locations, can be done without impacting the client. So imagine like you have a microservices architecture and you change something and somebody was accessing that URL from outside the architecture, like for example, a client or an external application or something. So that application will break provided it's dependent on that service. So you need to mask these changes, and for the outside world, it should be like nothing has changed in your system. So how do you handle that? An API gateway can help you with that. So with this advantage, API gateway encapsulates the entire internal system architecture. The next advantage would be to handle cross-cutting concerns like security, load balancing, rate limiting, and analytics. Now, these things are important when it comes to microservices or building any application. So essentially, you can have API gateway handle all of this, and basically the microservices can be free from such things. Okay, so you delegate all of that responsibility to API gateway. The next advantage would be authentication of incoming requests. So this is also part of security, which we spoke about. So API gateway can also authenticate incoming requests, and after authentication, the valid requests are only given to the service. Okay, so this allows to have a authentication on the entire microservices network. It can even aggregate responses from different microservices. So let us say client needs something and you need to collaborate with multiple microservices in the hindsight for getting that response. So API gateway, what it can do is it can communicate to multiple microservices, collate the response and give it to the external client. So this can be done by API gateway, and it can help you reduce the number of trips or round trips between client and server. And this can greatly improve the performance and user experience, particularly in mobile applications where network latency can be a significant issue. So this way, API gateways play a crucial role, and the role of API gateway is really crucial in simplifying the client side of interactions and managing different concerns. So this is the importance of API gateway as to why it's needed in microservices. Let us start talking about the functions of API gateway. So there are a few core capabilities that API gateway brings to your microservices architecture. The number one is request routing. So the primary function of API gateway is to route requests to appropriate microservices, and it acts as a single point of entry and routes each incoming request to the right service. This not only simplifies the client side, but also abstracts the complexity and the details of the underlying services for the client. Load balancing. Now, this is another feature or the ability of API gateway, where an API gateway often incorporates load balancing to distribute traffic across multiple instances of a particular service. Now, this helps improve responsiveness and availability of applications. So if a service is scaled up by adding more instances, the API gateway can distribute requests evenly across all instances. The next one would be authentication and authorization. So security can be one of the major concerns when it comes to microservices or any application, in fact. So API gateway can authenticate the client credentials and then forward the request to the right service. Rate limiting. So this is one more ability that API gateway can help you with. So API gateway helps you protect your services with the help of rate limiting. So essentially what rate limiting means is limiting the number of requests a client can make to any given service in a given amount of time. That is what rate limiting is. And this is done to prevent overuse, abuse, or prevent any attacks on your services. Then you have request and response transformation. So if you need to transform your request or response, so API Gateway can act as a middleman, and once it gets the request, it can transform the request and send it to the respective site. Aggregation of data from multiple services. So API Gateway can aggregate the data from the multiple services or microservices that exist, and it can unify the response and send it to the client. So this is about the capabilities of API gateways, and you can see it performs a variety of functions that can make it easier to manage a microservices architecture. It provides a central place essentially where majority of the functions are handled, and they can be common across different services. So this is about API Gateway. Now, what are we going to do and how are we going to implement API Gateway? So here is how we are going to implement API Gateway into our microservices project. So we have the microservices network or the microservices here. So these are 3 microservices. One is the review microservice, then we have job, and then we have company. These microservices have their own database, okay? And they all communicate with the config server, Eureka server, and the Zipkin server. Now, we are going to add another layer of API Gateway, which will be responsible for routing the external requests. So whenever you request anything in your application, whether it's a mobile app or it's from a client which is on a desktop, so these requests are given to API Gateway and they are handled by API Gateway, and then API Gateway will route those requests to the appropriate microservices depending on what the client is asking for. So this is a function that we are going to implement, and this is what our architecture is going to look like. So excited? So let's jump into the details. Welcome to this class. So let us start talking about how are we going to actually implement an API Gateway into our microservices architecture. So we are going to take help of Spring Cloud Gateway. So if you search for Spring Cloud Gateway on Google, you're going to land on this URL, which is the first URL here. And it is the official website of spring.io. So this is the official page of Spring Cloud Gateway. All right. And it's a part of Spring Cloud project, as you can see here. So we will be using this, and you can take a look at different features as well that it has to offer us. So you can see it offers a circuit breaker integration. It is built on Spring Framework 5, and it is able to match routes on any request attribute, and it offers predicates and filters as well. So we are going to work on this, and we are going to integrate this into our application. Okay. And how are we going to implement? So this is what the architecture will look like. So you will have this microservices here. We will have 3 microservices is what we have right now, along with their own copies of database, along with a config server, Eureka server, and Zipkin server with which they communicate. And then we are going to have a Spring Cloud Gateway setup like this, which is going to take care of all the requests. So without a further ado, let's get started. So now let us start setting up the application gateway for our microservices architecture. And we are going to make use of Spring Cloud Gateway. So let us head over to Spring Initializer. And here I'll change the artifact and name over here. So I'll say artifact as gateway, and name is automatically changed. So description is, this is gateway. So I'll just have description as gateway. You can have any description you want. That's perfectly fine. You have package name automatically generated, packaging jar, and Java 17. Just make sure you have selected Maven here and a valid or relevant Spring Boot version. Now I'll remove this from here. So I need to start adding the dependencies. So what are the dependencies that we would need for our gateway project? So the first dependency I'm going to have is Eureka. So I'm going to register this particular service with Eureka. I'm even going to have the Zipkin dependency. So Zipkin is another dependency that I wish to have over here. Okay. And then I'm going to say gateway. So you can see here Spring Cloud routing, which is gateway, and this is a simple and effective way to route APIs. So this is what I have added. Now if you go to explore here, you're going to see the pom.xml being generated. And this is the dependency that we are adding for this project to act as a gateway. So this is a dependency that will do the magic. So this is added. Now what we can do is we can download the entire source over here. So I've downloaded the file, and here you are going to see gateway.zip. So I'm going to unzip this file here, extract here. You will have the unzipped version, and now let's import this into IntelliJ. So here in IntelliJ, I'm going to go to Maven, and I'm going to add this project to this particular view. So I'm going to select gateway here, and this project gets imported. So now we have a project here in this particular view. All right. Now what I will do is I will go to the application.properties. So we have all the dependencies set. I'll hide this sidebar. So we have all the dependencies set. We need to head over to application.properties to do the relevant configurations. And I'll get some configuration from job service here. Okay. So I'll copy all of this and I'll paste the configuration here. Okay. We will remove everything that is irrelevant. For example, this is irrelevant, the database part. We don't need this. Even PostgreSQL part is irrelevant here. Okay. Now here, I'm going to call this as gateway, like so. And this is going to run on port 8084. So this is going to run like any other Spring Boot application, but it is going to do the job of routing the request to the relevant service whenever a request is coming in from the external client. So now here we have some settings related to Eureka, which we are going to keep as it is. We have Zipkin sampling rate as well, which is fine. We have config server, so we don't need config server here in this particular application.properties file. So basic configurations are done. Now we need to set some routing logic. So I have the routing logic written in a notepad file over here. Okay. So we need to add this to our application.properties. So I'll copy this and I'll paste it over here. So I'll say gateway, like so. So this is a logic related to the gateway routing. Now what does this mean over here? So here we are setting routes, which means this is a logic as to how the request from a gateway is routed. So for example, we have this first route set over here, and this has three parts. One is ID, URI, and the predicates. So you can see this is the first route, and you can see this with the help of index. Now the ID over here is company service. The URI is this. And here we have added the path. Okay. So ID is nothing but the unique identifier that is given to the route. Okay. And this field can be anything as long as it's unique amongst all your routes. Okay. So here we have everything unique. So company service is unique, job service is also unique. Then we have the URI part, wherein this is the address of the backend service that this route will forward request to. For instance, this particular service, company service, so any request to this service will go to this route. Then you have predicates. So this is a list of conditions that an incoming request must meet to match this route. And each predicate will have such pattern over here, which is used for matching. And if the match is true, then the request is forwarded to this particular microservice. And then you have more routes that we have defined over here. Okay. So essentially here in terms of predicates, we are specifying in this format. Okay. And this is like a inbuilt predicate sort of thing. So here you can see here we are using 2 stars for pattern matching, and this is a wildcard that matches any sequence of characters. So for example, company /1/2, anything will be matched to this particular route as long as it has company in it. Okay, so that is what this means. Same goes for job and same goes for review. So if you take a look at our jobs, review, and company microservices, so if we go to the controller here, so in controller, the entire controller is mapped to /jobs. Okay, and then the rest of the part keeps on changing. Okay, so what we have done is we have said /jobs here. Okay, so if you scroll up, here we have /jobs and here we have /jobs. So that is how it matches. But I noticed a small mistake over here. So here we are saying jobs. So here also we should have jobs. So it's plural. And let me check the same for review as well. So I'll head over to review. Here also I'll go. In review controller, you will see it's reviews. So essentially it's plural over here. So we need to change it to plural and not keep singular. So I'll go to company as well and we'll just verify. So here also it's companies. So we'll keep this plural. Okay. So yeah, this should work now. And I have specified the port as well. So this is the setup done for Spring Cloud API Gateway. Okay, so we have the project setup and we have the necessary configurations done that we need our gateway to function properly. So that's about this class. I shall see you all soon. Thank you. So our gateway server is set up and configured. Now what we can do is we can add some configurations to our application.properties of gateway to enable some behind the scenes. So what I would be doing is I would be switching over to Notepad here, and I have some properties written here. So I'll copy these properties and I'll paste it over here like so. Now what do these properties mean? So these properties are used to set the logging level of various components of our application. So this first part, logging level root is equal to info. This sets the default logging level for all the loggers in our application to info. And this means that any logging statement by default with the level of info, 1 or error will be output in your application's log. Okay. And then we have the next statement over here, which says like logging level Spring Framework Cloud Gateway Route Definition Locator is set to info. Now what does this mean? So this particular line sets the logging level specifically for route definition locator class in the Spring Cloud Gateway to info. Okay. Now we have the third line as well, which sets the logging level for Spring Cloud Gateway to data of trace. So within this org.springframework.cloud.gateway, all the classes will have the logging level of trace. And this is very detailed level of logging that includes debug set statements as well. So this is what we are setting in. Okay, this is going to help us understand what is happening under the hood. So we have the configuration done for gateway and our gateway is ready. So what I'm going to do is I'm going to head over to our main application and I'm going to run gateway. So we are going to have gateway added over here as a service. And now if we head over to our browser and if you head over to Eureka server and if I refresh, we will see gateway being added as one of the services that exist in our microservices architecture now. So now since we have the gateway up and running, it's now time to test this. So I'll switch over to Postman here. And what I'm going to do is I'm going to create a new collection over here and I'm going to call it as gateway. Now what will this collection have? This collection is going to have the URLs that will point to the API gateway. What URLs should I take over here? So I'm going to expand the company microservice over here. So this company microservice collection, and I'll duplicate the collection or duplicate the API to create a new company. I'll duplicate the API to get a new company, and I'll move them both over here. Okay. So we'll use this duplicate method because this will save some time. Like we just have to change the port number. So this will help us save some time so that we can move faster. And here I'll take 2. So I'm taking only 2 requests into gateway. So we'll be testing gateway with only 2 requests. So we'll do a post request and then we'll do a get request. So that will give us enough idea as to how gateway is working. So I've moved them both and these both are copies. So review is done. Now we can do for job. So for job microservice, I'll duplicate this one. And here I'll duplicate the get one. So this one and then the get one here. Right. So now I'll collapse everything. I'll close this. Now let us change the port and everything for all the requests. So we'll start with the companies. Okay. So I'll say 8084/companies, and I'm going to copy this URL and add it over here. Okay. So this is modified and I can hit save. Now I can even trigger this particular API and get the company created. So let us even do that. So I'll say send, and you will notice that we have sent the request from 8084, and you will see that the company is created over here. Now, the moment we triggered this API request, if you head over to IntelliJ and if you select gateway application over here, and if you scroll up, you will see a lot of logs that we have enabled over here. Okay. So one log so here you can see the match happening. So 8084/companies. Okay. And if you scroll up here, so you can see this line over here. So pattern/companies matches against this value /companies. And this is how the forwarding works. So essentially, whenever a request comes into gateway, the pattern is matched against the configuration that you have specified, and then it is forwarded to the relevant URL. Okay. So you can see and learn from these logs here. So we will get back to Postman. Now here in Postman, I'll start modifying my other APIs also. So I'll just copy, or let us copy this entire port number, and I'll update this here. And also I'll copy the entire URL and paste it over here. Now if I try to get companies, this API is also going to work. Okay. So I had one company already added and I added one more. Now here, if you go to reviews, we need to do the same thing. In fact, we need to do the same for all the requests over here. Okay. So I'll just do this for everything. Now this is a get request and we have one review existing over here. Okay. But you can also play around with the post request if you want to. So I'll just trigger a post request as well. So here I'll say send, and you'll see review being added successfully from the gateway port. And let us do the same for jobs as well. So I'll say 8084 here. Okay, so I'll have to type in, it seems. And I'll copy this URL and I'll paste it over here like so. And for this URL also, I'll change this to 84 and I'll copy this and I'll paste it over here. So we are done with the changes. Now let me post a job. So I'll post a job and you can see job has been added successfully and I can get the job. So you can see we're getting like job, company, reviews and everything. And there are a couple of jobs that have been added here. Okay. So indeed it is working perfectly fine. There are no issues as such. All right. What you can do is you can right click over here and say close all tabs and say save changes to all the pop-ups that come in. So it will save all the requests for you in Postman. All right. Now, I wish to show you one more thing over here. So if you go to, so here we have Eureka server running. Now I wish to show you Zipkin as well. So you can say Zipkin here and you can go to this dashboard. All right. And you can say run query. Now you will see few requests that we have triggered just now. And this was the request that we triggered last. And this is from the job API, I believe. Right. So if you say show over here, you can see how the request flowed. So the request first went to the API gateway. And then from there, it went to jobs, company service, review service, company service, review service, and then we got the final result. So all the requests are now being routed via gateway. And you can take a look at different requests over here. If you take a look at company requests, so this is the API request to create a company, and we went through API gateway here. So you can see services it touched is 2, total spans that exist were 3, and this was the trace ID. All right. So you can go over here and you can just play around and see. So every request is now going through gateway. If you say expand all, you will notice this. Okay. So gateway is indeed in action. And now the benefit over here is you have this single URL, localhost colon 8084. And you can give this URL to anyone. Okay. And this URL / jobs is for jobs microservice / company is for company microservice / reviews is for review microservice. But this detail that there are different microservices for different functions is only for you. Like you don't need to expose this to the entire world, right? So there is one single URL over here. And if you deploy this onto a server or something, you can have a domain name mapped over here. And then it will work seamlessly. So external users won't know actually what is happening behind the scenes, because there is only one URL that is taking care of everything. So this is API gateway in action for you. I would request you all to play a bit around with this one and go hands-on a little bit and understand as to how this is working. So that's about this class. Thank you, and I shall see you all soon. Hey there, welcome to this class. So we have our Spring Cloud Gateway server ready, and we have already done some configuration that we need for gateway to function properly. Now here, I wanted to talk a little bit about HTTP versus LB. So HTTP is the standard HTTP protocol wherein you use this as a part of the request, and all the requests that you trigger go through the HTTP protocol. Okay. And the services using HTTP are located directly using the URL, and you specify the host and port there. So this is something that we are aware. Now, what does LB mean? So LB stands for load balanced, and this is specific to Spring Cloud, and it indicates that the service should be located via a load balancer. So let me give you an example. Here we have a job service and we are using HTTP over here. So let me remove this HTTP and I can have LB over here. Now LB means load balanced is what I mentioned. Now when you use load balanced in a URI, it means that gateway would use the Spring Cloud's service discovery mechanism to locate an instance of the service. Okay. And usually when you use LB, you cannot use the host and the port number, but instead you have to use the service name over here or the service ID. So here, if we go to Eureka, this is the service name that we have. So I'll copy this and I'll come over here and I'll paste it over here. Now, why would you do this over HTTP? So I'll tell you one reason. So here, HTTP is good if you have a single instance of microservices running. But when you have multiple instances, for example, let's say you have 10 instances of one microservice running, then in that case, you need to load balance the request. Now, what I mean by load balanced, you need to make sure that the requests that are coming to that particular microservices are distributed evenly across all the instances that are active right now. So for example, for job service, if you have 10 instances up and running, So let's say this service is getting a lot of traffic and we have added multiple instances. And in that case, which instance should get the traffic? So that is something that is decided by load balancer. But to configure it, you need to give this over here. So you need to have LB colon the service ID. So in that case, the discovery will happen with the help of service ID. Now under that service ID, there can be 10 instances running and the request will be distributed evenly. So here with HTTP, you are specifying a specific instance over here. So I want my request to go to this instance. But here you are just saying, I want my request to go to this service. Now it does not matter how many instances for this particular services are running. Because in this case, there will be one more instance or there might be one more instance of company service running. But there is a possibility that that instance is running on a different port. So that won't be utilized or that won't be called. So when you use service ID, that is the benefit that you get. Now let us test this. So we have load balanced this particular thing. Okay. And what I will do is I will run one more instance of job microservice over here. But the question is, how do you run one more instance? So you can't just right click and rerun. You don't have any option here. So instead, you need to go here at the top. You need to say edit configurations. You need to select the configuration for job microservice. So here, these are all the run configurations for our services. So I need to duplicate this. So I'll say copy the configuration, a duplicate is created. And now I'll specify a distinct name for this particular configuration here. So let's say our job microservice is running at 8082. So I can run this at 9082. Like so. Now, how do we run this? So in order to run this, we will have to pass some extra parameter. Okay. And why do we have to pass this? So I'll just say apply and I'll say okay. So here, if you come to the job service properties, you will notice that we have specified the port number over here. All right. But the instance that we are running now, we want a custom port. So we don't want to go with 8082 port. So we need to override this during the runtime. How do we do that? So in order to do that, you need to click on modify options. You need to say add VM options. And here you need to say -t server dot port is equal to 9082. So this is an extra parameter that you are passing during runtime and that will be taken care by IntelliJ. Okay. Now I need to hit apply here. Just make sure that you hit apply and you say okay. Now you have one run configuration over here. So you need to select that and you need to say run. Now the moment you do that, you will see a new run configuration or a new service appear over here. And hopefully there should not be any errors. Okay, so you can see the registration is successful, 204, and the application is up and running. Okay, so we have now 2 instances of job microservice running. So I'll switch over to Eureka now and let us refresh and see what happens. So here for now, without refresh, you are seeing one service ID and one instance over here, which is running on this port. So if I say refresh, can you see there are 2 instances now that are up and running. Okay. Now, if we go to Postman, I can actually call any of the instance. So I can hard code the instance port number and the host over here and I can call. So if I do a call to 8082, it will go to the first instance of jobs. If I change this to 9082, it will go to the second instance of job. But we don't want to handle this, okay, round robin. So what we will do is we'll send the request through gateway. So now here, if I say get job, the job is empty, of course. So I'll create a job and I'll try getting it. So here now you will see from the user standpoint, I'm interacting with the gateway URL. And for us, I don't know, like we don't know like in backend how many instances are running. Okay. So I just need to interact with the gateway, and the request is load balanced, which means that depending on the load, gateway is going to distribute the requests that are coming to different instances depending on the traffic. All right. I hope this is making sense. So the job of making sure that the load is distributed evenly is taken care by Spring Cloud Gateway over here. And you can go to your browser, open Zipkin, and you can say run query. And you will see over here. So you can go over here, you can select this, and you can see this particular request is, so if you select the jobs URL here, so here we are not seeing the port yet, but ideally, if you see the port over here, you would have got the idea as to how it's working. But what I want to show you is, for us from the user standpoint, it's working perfectly fine, and we are not aware of what is happening. So here you can see the port number, see 8084. And if you send a lot of requests, you will see some requests going there as well. So it is distributed depending on the load. Okay. So we don't need to worry about this, but we have Zipkin and all the tools to get an idea of what's happening. So in general, if you use HTTP, you know the exact host and port of the target service, and you know it won't change. But when would you use LB or load balanced? If you want to use the service discovery and load balancing mechanism of Spring Cloud, which is more flexible and robust in microservices architecture. So now I'll come back to our project and we will update this for everybody. So we can like change this LB colon, or I'll just copy LB here, and we'll make everything load balanced. And now I need review service. I'll copy the review service here, like so, and I'll paste it over here. I can go for the company service as well, and I can paste it over here. So I'll paste it over here. Done. Now I can restart all my services and test the changes. So it should work perfectly fine, but now we have moved from HTTP to load balancing for our microservices. So that's about HTTP and LB. Thank you. So we now have all the requests being routed via our API gateway, and we are making use of Spring Cloud Gateway for this. Now there is one thing still left. So if you head over to our browser here, if I head over to Eureka URLs is still some other port number, and it is not yet going through gateway. So what you can do is you can even route Eureka server from the API gateway that we have configured. Now, how would you do this? So to do this, I'll head over to our configuration file over here, which we have created for API gateway. So right now I'll switch to gateway application.properties, and I have it open here. So here we need to add a few more routes to configure the Eureka server. So I have those routes written over here. So I'll simply copy them. So I'll copy this first 3 lines, and let us add these first 3 lines. So what have we added? So we have added Eureka server here. We have pointed it to this URL. So this is a URL where our actual server is running. And then we have specified the path where we want to access. So if I copy this path, and if I head over to the browser, and if I say localhost 8084, so I'll say 8084, and if I go to Eureka/main, I'm going to get an error. And this would give an error because the request is redirected to Eureka/main on 8761 port. So it's being redirected to /main over here, like so. We don't want to do that. Okay. Now, how do we tell the route to transfer the request to the root URL over here? So if you look at the configurations over here, what we have done is, if the request is coming on 8084/jobs, it is simply being routed to 8082/jobs. So this path is not changing over here for any of the microservices that we have. But for Eureka server, there is a need for us to change the path over here. Now, how do we do that? So we can do that with the help of filters over here. So we need to take this filter thing over here and I need to paste this over here. So this tells that whenever the request is being routed, it does not need to be routed to /eureka/main, but instead it is supposed to go to /root URL when you are calling 8761 or when you are routing the request to 8761. That is what it means. Okay. Now let us try running this and let us see what the output looks like. So I'm going to restart my gateway application and let us wait for this to turn up. Meanwhile, we'll head over to Eureka server and I'll hit refresh. So it's not there yet. And it's there now. So gateway is up now. Now what I can do is I can refresh this URL. So localhost :8084 Eureka/main. So you can see here, we are seeing the Eureka server as well over here. Okay. So it is working perfectly fine. Okay. In case if you don't see the CSS and HTML being loaded, so I have one more piece of code also written over here. So you can simply add this to load all the static files. Okay. So what you can do is here at the bottom, you can add this as well if the static files are not being loaded. Now what I mean by static files is files like JavaScript, CSS, and some basic things or basic elements that beautify a particular web page. So if that is not being shown to you, you can add this as well. So essentially your file would look something like this. Okay, so you would be adding these two things into your file. All right, and I've added this. Even if I restart, it would work perfectly fine for me. But for me, I'm seeing the CSS already being loaded. So that is not a problem here now. But if I refresh, the connection is refused because the service is not yet started. So gateway is down. So if I refresh from here now, you can see we are seeing the Eureka server being loaded from the gateway URL. And this is amazing because now you have a single URL for everything. So if someone is doing some administration related work and if he needs to access Eureka server, he does not need to go to the actual Eureka URL, but instead you as an application developer can configure the gateway to show Eureka server as well. So there is only one URL now that is being exposed to the outside world. Isn't that amazing? Yes, it is. So that's the power of Spring Cloud Gateway. That's all from my side. Thanks a lot.